Hello everyone and welcome back. What you see in front of you is a shed I'm building right now to cover my water filtration board. I have a system that I've built to filter and purify the rainwater for my rainwater harvesting system. This system is good for an entire house or an entire home, and it produces about 3.5 gallons a minute of purified rainwater. So so the shed in front of you is not complete, of course. I need to shingle the roof and still put a front on it, and I need to add a little bit of dirt here where all these where I have these boards. It's a low area, holds water, and so I don't feel like getting muddy. So let me take you underneath the shed and I'll show you and explain to you how this water filtration board works. Okay, so if you have not watched my previous videos over my rainwater harvesting system, just if you're wondering where the water comes from, you'll have to check out those previous videos to see how all that is set up. This video is strictly over water filtration and purification. So what you see in front of you is what I like to call my water filtration board. This is also commonly seen in a type of home called Earthship. It is a completely sustainable home. They collect rainwater off the roof, and this is very similar to the setup they use to filter and purify their water. What you see here is very similar. Now I've added one more feature to this, and I'll show you later. But let me start here, at least where the water comes in. Okay, so starting here at the beginning, here is my water inlet, I would call it. This is coming from a rainwater harvesting tank of mine, and then this is a 3/4 inch ball valve here. From there, I'm not going to explain each one of these little adapters. This is all 3/4 inch PVC. So basically, when you work with PVC, it's like fitting everything together like a puzzle in a way. So again, I'm not going to go through these minor things. What I'm going to hit on is more of the filtration, the pumps, the battery. Okay, so moving on, this first filter is a Rusco spin down filter. Now you'll see there are two other filters that look exactly alike. These are also Rusco spin down filters. The only difference is the actual filter inside. This first filter here is a 100 mesh filter. So what mesh means or stands for, here's the only way I know to explain it. What mesh is in 1 square inch there are 100 little squares within that 1 square inch. That's what 100 mesh is. So if you could imagine how large those squares would be if there were 100 little squares in 1 inch, you could tell how tiny they would have to be. Well, that's what this filter is, a 100 mesh. And then this filter down here is a 500 mesh. And then the next one further down is a 1000 mesh. So as the water gets pushed through this filtration board, it filters down the particles or debris in there from the largest down to the smallest. Okay, so this first filter is just a 100 mesh filter, and this is here, one of course to filter out our drinking water, but two, notice it's placed before the pump. Here's my pump here. Now it's placed before the pump to remove any large debris that could possibly damage your pump. So it's good to have at least one filter before your pump, pre-filtering any large debris out of your water. Okay, after the water goes through this filter, it will then travel down here into this. This is a Remco 5 gallon per minute pump. And I believe it's a 15 amp max. And what I've done is put a 15 amp fuse in here, and I have a quick connect and disconnect cord here. So this makes everything very easy. I don't have to always take these bolts off here if I need to disconnect the battery. I have this quick disconnect and connect here. Okay, just a little closer look at this quick disconnect and connect here. It's just a very simple 2-prong connect and disconnect adapter. Makes things a lot easier. Saves you a lot of time. See if I can get this back together with one hand. I can. There we go. So the pump runs off. Actually, I do not know the size of this battery, but it'll run about 3 hours. This pump can run at least, put it this way, at least 3 hours on this battery. What I do not have done yet is a solar panel that will keep this battery charged. I just need a small solar panel, and then I won't ever need to charge this battery again. I've charged it once so far. And so of course now, since I'm running this off a battery, so that means one thing: this is a DC pump, so it won't plug into a conventional wall outlet. However, you can buy a pump that can do that. I did not have an outlet anywhere near, so it was actually going to be cheaper and easier for me just to run this off a battery and hook it up to a solar panel. Another thing is, it's completely off grid now too. Even though I don't need it to be off grid, I'm in the middle of the city, but it's neat just because it is off grid now, and it's its own working water system. Okay, so after the water comes through the pump, we get pumped up here, and to the left here I have a pressure gauge. This pump turns on at 45 psi. Something I forgot to mention: the pump has an automatic pressure switch. What a pressure switch is it's a device inside that pump that, when the pump senses a loss of pressure, so when you were to open, let's say you turn your water on, all the pressure runs out of the pipes, and the pump senses that, and then it will turn on, and it will pump up to 60 psi. So it turns on at 45 and off at 60, and then that does this automatically for you. If you did not have a pump that had an automatic pressure switch in it, they make a electrical pressure switch, and you can buy them from local hardware store for, I'm not sure how much they are, but I don't reckon it would be that much. So that's another way to configure this if your pump does not have an automatic pressure switch. So from there's another Rusco spin down filter here. This is a 500 mesh filter, and you can see here, if you get a buildup, I'm never going to have a buildup of a lot of dirt here. These, you can actually see the filter's a little dirty now. I think you can tell from this shot. But yeah, you could just purge these here. Yeah, you heard the pump kick on. It sensed the loss of pressure and then kicked on automatically. So I have two other, I don't know, what do you want to call these, outlets here, or two other valves. These are both 3/4 inch ball valves again, and that's for my water hose or garden hose. In a whole home system or an entire house system, these connections could be used for a washing machine or any other water that you don't need drinkable or potable. So toiletry, yeah, this could be great for your toilets as well right here, because there's no need to filter your water to drinking standards if you're going to use it for toilet water. So that's just what these connections are for. Now if I turn this on, the pump will kick on. So there we go, made a little mess, but okay, so that's what this option's for here, and I recommend these. There's no need in wearing out your filters if you don't need to. So right down here is the third Rusco spin down filter. I'll put a link below on the description where I bought a lot of this. Some of the toughest things when building something like this is just learning all the names of all the products and where to buy them. So that's the toughest thing in building this. Putting it all together is quite easy. Okay, so moving on, I have another 3/4 inch ball valve here. This allows me to, if I turn this off here, it allows me to work on this filter down here while leaving the battery plugged in and everything else on to the left side of this. So that's the purpose of this valve. Now there's a white 3/4 inch PVC union here. Here's a better shot of that PVC 3/4 inch PVC union, and you can see too now I've turned that ball valve off, so there's no water coming to this filter now. And actually, to take this filter off, there's the little red button up here that releases the pressure, and you'll need to make sure you cut your ball valve off before you release the pressure. once you do that, you can actually remove this blue housing. So this blue housing is basically what's doing all the work. Everything that we've done up to now is pre-filtration for this filter. This filter alone will purify your water and take all the sediment out of it. This is a 6-candle ceramic filter. Ceramic, if you've ever seen it, just looks like a rock or a stone, and it's kind of rough to the touch. I'll take this blue housing off in a second, and I'll show you what these filters look like. Now there's 6 of them because ceramic is it's a low flow material. It's so coarse, the water does not flow quickly through it. So that's why there's 6 of them. So you get a large amount of water at one time, and this can produce, man, I believe it's I believe it's 750 gallons in an hour. But realistically, in what I'm getting out of it, I can get like 4 gallons a minute right out of here, right through here to about 4 gallons a minute, because I only have a 5 gallon per minute pump, and so it takes some power to push it through everything. So you don't get 5 gallons a minute. You don't get 5 gallons a minute at the end of your filtration system, but 4 gallons a minute is plenty. One more thing before I show you this filter, and it's also purifier. It's a purifier because it does remove bacteria. This filter is rated in microns, and it's a 0.9 micron. Actually, the filter's name is a Dalton Rio 2000. I'll post a link where I purchased it. I can't really remember where I did, but I believe it was on Amazon, but I'll post a link. And this filter is the most expensive. It's going to run you about $230–40. And the Rusco spin down filters I showed you earlier, these here, I believe they're about $65 a piece. 65 bucks. So this is a 0.9 micron, the filter or purifier. And so what a micron is, the only way I know to explain that is that there's, I believe, 25,000 microns in 1 inch. And your hair, one strand of hair is equivalent to about 10 microns. So you could realize how small of area this water is being pushed through with this filter of a less than 1 micron. This catches 99.99% of all bacteria, this filter here. So why we've put these other filters before it is to pre-filter, to get a lot of the dirt and sediment out, so we don't wear this filter out. If I didn't have these pre-filters, this filter would get dirty almost immediately because it would be catching all the largest material, when really it's designed just to catch very, very small material, bacteria, which are tiny. Alright, one more important thing. I had told you now that this is a less than 1 micron filter, and that this over here, this is a 1000 mesh, and that one down there is a 500 mesh filter. So what's the difference between microns and filters? They're each a different unit of measurement. But there is a conversion chart, and if you just Google micron to mesh conversions, you'll get the chart. But quickly, this 1000 mesh filter is equivalent to around a 12 to 15 micron filter. That's what the conversion would be. So if you want to get an idea of how much more this ceramic filter filters out this one, again, less than 1 micron. And this one here, if it was in microns, we would call it about a 15 micron filter, but it is a 1000 mesh filter. Okay, so I'm going to show you the 6-candle. I'm going to show you this filter now, and then after that I will show you where this pipe leads. This leads to one more feature on the system, and we'll get to that. Okay, I removed the blue housing, give you a look at the Dalton Rio 2000 ceramic filters. You can see there's 6 of them. Go around this entire thing. I'll show you later how I clean it and how to remove them. It's quite easy though, they just screw right into the top. And so when you do clean this though, you just use a green bristle pad, or I'm not quite sure the name of it, it's just like a green kitchen pad you would use for cleaning dishes, and you scrub these ceramic filters lightly until you remove like the top layer, and they're good for around 50 cleans. It says you can clean them about 50 times. So a couple more things. This little tool down here on the ground this tool comes with the filter. This is the tool you use to remove that blue housing. And then here again is that ball valve I had, and so whenever I turn it on, now I've put this blue housing back on. So when I turn this ball valve on, the pump should kick on for a short amount of time to fill the water that I dumped out of here, to fill this back up with water because I dumped the water out. So let's see, everything works properly, and if I hook that battery connection back up good, it should turn on just for a brief second or two. Few seconds, there it goes, it's full. Okay, so I showed you where that pipe coming out of that filter with the blue housing. So it pokes out right here through the shed I'm building over it, and then runs up, and then it goes into the attic. I'll show you where it comes out. Okay, so that pipe runs through the attic, pokes out here in the garage. Now that is, I went from 3/4 inch PVC down to 1/2 inch PVC. So now that's a 1/2 inch PVC poking through the attic, and that is a 1/2 inch PVC ball valve right there. And then this adapter is a 3/4 inch to 1/2 inch. It's 3/4 inch because I said I had a 1/2 inch PVC, but PVC is thicker than copper, and this is a copper fitting. So I had to use a 3/4 inch on one side, 1/2 inch on the other side. What you see in front of you is a UV light purification system. UV light kills bacteria. And so the one most important thing you should know about a UV light system is that it goes at the end of your filtration and purification system. The reason for this is because if you don't pre-filter your water, bacteria are so tiny that they'll hide behind the sediment in the water, and then they won't get the proper exposure to the UV light because they're essentially getting shade from dirt particles or from whatever particles are in your water. So earlier I was talking about the filters in mesh and in micron, the sizes of the filters. So you would need to pre-filter your water down to 5 microns. You would need nothing larger than 5 microns in your water for this UV light system to be effective. Now I'm filtering mine down less than 1 micron. The filter in the blue housing was supposed to remove 99.99% of bacteria, and so is this filter as well. Or this actually is not a filter, just a purifier. This is supposed to kill 99.99% of bacteria. And it does. I've had the water tested from City of Houston laboratories, and it passed both for total coliform and E. coli. Also in the video description below, I'll post where I purchased this. It's a Sterilite Silver UV light system. I purchased it from freshwatersystems.com. I had a horrible experience with them. I won't say much more about it on this video, but I will do another video just over a company and product review over this product. But what I can say is I highly recommend you do your research before you decide to do business with freshwatersystems.com. So this feature here, this is a monitor, and this monitors the brightness of the UV lamp inside the cylinder here. And you can see up here it says 99. That 99 represents how much life the bulb has in it. And so this bulb has 99% of its life left. And so when it gets down to a specific percentage, then it's time to change the bulb. But regardless, you change your bulb yearly or annually. A few very important things just to know if you're going to buy and install your own UV system. Number one, you'll need some type of electrical outlet, because this stays on 24/7. Once you plug it in, you leave it on. So, and that's maybe one of the cons of it as well, is yes, it does take electricity, But on the other hand, this is a mechanical way of purifying your water, which means you're not adding any chemical to it. So it's the freshest, purest water that you can get. Another thing is the copper fittings that I've talked about already. It's copper because UV light will deteriorate PVC and plastics. It'll also deteriorate other materials. However, copper is a good material to use with the UV light because it's very resistant to the UV light. Another thing is, yes, when you work with different materials, certain things can be more troublesome. Just for example, here, where I connect the copper adapter, it's a 3/4 inch copper adapter to this the UV light cylinder here. You have to use Teflon tape, and that's commonly used on threaded materials when working with water or liquids. But I also had to use a pipe sealant as well. It's like kind of like a putty that you put over the threads as well to help it to not leak, because I had to do both. I did just the Teflon tape, but it leaked still. Just a few things to note. That's something you'll run into if you plan to do this and if you plan to use copper, and I recommend that you should or let me recommend that you should not use PVC. So that's a few things to note when doing this. Also, know that copper is more expensive. It's a lot more expensive than PVC. Each one of these little adapters here, they'll run you at a local hardware store about $10, and if you can get them from a wholesale shop somewhere, maybe you'll get 30% off that. Just a few things to note if if you plan on setting up your own UV light system. That's a couple issues you'll run into, or just helpful things to know. Okay, I'm going to turn this valve on and show you how much water we have coming out of this blue hose, and this is about 50 foot of pipe and hose combined, maybe a little bit more. A 5 gallon per minute pump, and I'll show you it's getting about 3 gallons a minute at the end of this line.